Hello class, I'm Cody Buntain. I'll be your professor this semester for INST414 on data science techniques. This is my first semester back at the University of Maryland as an assistant professor. I'll talk through more about my biography in a few minutes, but I wanted to take a moment to introduce myself and give you the opportunity to see me on camera. Hopefully some of you will come and see me during office hours. You'll get to see me more. But I wanted to give you a chance to see what I look like, see who is going to be leading this course for you this semester. And now, without further ado, let's start our first lecture. This will be the first time that I'll have my video on throughout the lecture. For the remainder of the lectures throughout the semester, you'll primarily just see our slides and my disembodied voice, but I wanted to give you the chance to see me and get to know me this first week. To introduce the class, this is INST414, Data Science Techniques, as I mentioned. In this lecture, I want to go through a number of pieces of introduction and course logistics to introduce the course, what we're going to be doing in the course, and give you a good foundation for the rest of the semester. So first, as I mentioned a couple of times, this is 414, Data Science Techniques. If this is not the class you're expecting, wait, this isn't woodshop quote from hackers here falls kind of flat when we're not actually in class. In person, but expect to see these kinds of jokes throughout the semester. This class is online and asynchronous, so there isn't a particular meeting date or meeting time for the class, though there will be opportunities to meet with me during office hours, and I'm hoping you will join me throughout the semester at bi-weekly meetings to discuss your projects, so you'll get to see me and your TA there as well. So first, who am I? As I mentioned, I'm Professor Cody Buntain. I'm assistant professor in the School of Information Studies, so the iSchool here at the University of Maryland. Prior to that, this is my first semester back here. Prior to that, I was assistant professor of informatics at New Jersey Institute of Technology. This is after I got my postdoc at New York University's Social Media and Political Participation Lab, which is now the Center for Social Media and Politics. After I got my PhD, I was also an intelligence community postdoctoral fellow, working for the Office of the Director of National Intelligence and the START Center here at the University of Maryland. And my PhD actually is also in, or from the University of Maryland in computer science. I was a PhD student under Jan Goldbeck in the HCIL, and I'm really excited to be back. Prior to getting my PhD, though, I was also the director of research for a small cybersecurity company. We did defense contracting, primarily working on anti-tamper, so weapon systems and their protections. And this company eventually got bought by Raytheon in the early 2010s, and I left soon thereafter. So that's sort of my background that led me to where I am now. My work follows or falls into one of these three main categories, looking at crisis communication. This was my original dissertation work. How do people use social media in the aftermath of crises, and how do we understand or identify high-quality information during these times of stress? I also look at political participation, political engagement, social movements, and now more recently on online information quality. So this is disinformation, online manipulation, these kinds of areas. Now, the tools for this are pretty varied. It runs from text mining to large-scale cloud analytics to machine learning to network science, all pieces that we'll talk about in this course. And I primarily apply those tools to social media, Facebook, Twitter data, YouTube data as well, but also online news data. So the news you consume is extremely high signal for a lot of kinds of information that we care about in terms of information quality. So outside of work, though, you'll see references to movies throughout lectures, primarily because I'm a big movie fan, though I have less time now and COVID has changed how we engage with movies. I also have a motorcycle. This is one of my COVID purchases. Really my only big COVID purchase was to pick up a 1995 BMW R1100 RS. And then I rode it from DC down to Florida, about 1,000 miles in the summer of 2020. As, again, a crazy pandemic response. And then I'm also a big board game fan, so you'll see some examples or references to board games throughout the year as well. So that's who I am. You also have a teaching assistant, Tanishka Kaushik, who will hopefully take the opportunity to introduce himself on the introduction, discussions, and ELMs, and you should engage or should have opportunity to engage with him a great deal over the semester. If we were in person now, I would ask you to introduce yourself, and I'd run through the room. And absent of that, I have a discussion board where you can go and introduce yourself there. Crucial things that I want from you are your name and pronunciation if you can, pronouns that you prefer, and then what you hope to gain from this class. Hopefully that'll be useful information for you to look back on, but the preferred name and pronouns will be super useful for your cohort, your other students, and for me as we engage with you throughout the semester. Speaking of engaging throughout the semester, a couple of notes on etiquette. When you're referring to your professors or your teaching assistants, ideally you should use the title and last name. So for me, this might be Professor Buntain. I'll have some examples. For your TA, might be it Mr. Kalshik or whomever. Unless otherwise stated, the safe assumption is to use title and last name. So regardless of gender, this is the important piece. For me, though, if you call me Professor Buntain, or Cody, I don't really care either way, as long as you're respectful about it. My pronouns here are he, him. So that's it for introductions. I want to go through now, talk about the course. In terms of course material, what do you need? There are a couple of things. We'll have a few textbooks of value here. The first is Mining of Massive Data Sets. I'll talk about why this is valuable when we talk about the course objectives. But I'll refer to this textbook as MMDS, the Mining Massive Data Sets textbook. You can check it out online. You can get it for free, actually, at mmds.org. It's developed by Yair Leskovic and his colleagues at the SNAP lab at Stanford. It's a really good resource for dealing with large-scale data. And I'll refer to a number of chapters through it throughout the semester. In addition, we have the Introduction to Machine Learning with Python book by data scientists, or a guide for data scientists, rather, by Andreas Müller and Sarah Guido. So I'll refer to this as IMLP throughout the semester too. This book, while is not as freely accessible as the MMDS, you can get it at the UMD library. You can get an ebook there for free. There's also a GitHub repo for that book, so you can see the code they used throughout. That's it for textbooks. Now I want to talk briefly about prereqs. So this course has a number. The first is 201 and 301. This is Introduction to Information Science. Really what you should be taking from that class, what are the roles of information in society? How might tech be problematic? And how might we use technology to motivate positive change? Really, what you've learned from those classes, it should help guide how you approach this class. So when we talk about data mining techniques, hopefully you'll be using those techniques to advance this positive change. Over the course of the semester, you'll be responsible for a number of Medium articles where you do some analysis on your own, and a semester project where you potentially collaborate with some of your fellow students, and the insights you might be looking for hopefully will be informed by your experience in 201 and 301. In addition, this is a data science class, so there's a programming aspect that's pretty clear. You don't have to be proficient in Python. That's not essential for the class, but the examples I will provide are primarily in Python. I have a wide variety of experience, though, so if you don't want to use Python, R, Java, Ruby, Scala, all these are pretty decent substitutes. I am less experienced with R than I am with the other ones, though. If you want to use something like Prolog, don't make me too upset by using something that's really not great for the class. But if you don't want to use Python, that's no problem. I do expect you to have some proficiency in programming, though. Also, you should have Psych 100 under your belt. This is Intro to Psychology. The main things you need from that class is some experience with research design and research ethics. In fact, when I was at New Jersey, Julie Ansis had come recently from Georgia Tech to start the cyber psychology program. So there's actually a nice overlap between the kinds of things we may do in this class and what you have experienced or what you may have learned from Psych 100. Lastly is INST414, Stat 100, and Math 115. So hopefully this gives you a good foundation for statistics and pre-calculus and mathematics. If I say something about hypothesis testing, you should have some familiarity with what that means. Same thing with linear regression. You should be familiar with that to some degree based on these stats classes. And then I really hope you'll have some expertise with linear algebra. You don't have to have a huge amount like inversions or things like that, but hopefully you do have enough experience to know what vectors and matrices are. If you don't, or you don't feel comfortable with those terms, I'll address them over the course of the semester, but I would like to know, just so I can modify my expectations if you feel completely uncomfortable with vectors and matrices and linear algebra. Outside of the classes and prereqs, I do have some expectation that you will be proficient in the use of command line, or at least comfortable with using the command line or the terminal, since a lot of my examples use Jupyter Notebooks or Jupyter Lab. It's easier, in my view, to engage with Jupyter if you're using the terminal, and some of the examples I have use the terminal as well. So hopefully you have some proficiency there. If you don't, that's absolutely cool. Reach out to me and I can give you some additional resources that'll help you out with that. And then finally, all the material for the course is going to be in Elms. If you're seeing this content, hopefully you've already gotten to this point in Elms. That's it for prereqs. Now I want to talk about what is 414. So what are we really going to do in this class? So if you go to the course catalog, it's pretty substantial actually. It's a large chunk of text, way more text on a single slide than you should ever have. But I'll read you some highlights here. So the course is about exploring the application of data science techniques to unstructured real-world data sets. It's not always the case that you get high-quality clean data. In fact, it's very often the case that you don't get high-quality clean data. This may include open source or open intelligence data sources, social media, Wikipedia, all those kinds of data sources are free game for what we'll do. Then we'll focus on techniques and approaches that allow the extraction of information that's valuable for both experts and non-experts. So this non-expert piece is particularly important. If you want to be doing good data science, you need to be extracting good, understandable, actionable insights that you may not have to be a complete technical expert to understand or take action on. And oftentimes in the real world, in your job or an industry, if you're doing some sort of data science analysis, you want to tell that to a stakeholder, a boss, somebody out in the community, you need to be able to explain or communicate that information to them without having to rely on technical jargon about how you did it, but still be able to get the point across. This course will explore approaches to extract insights from large-scale data sets, so not just unstructured real-world data sets, but ideally large data sets, which is why we're using the Mining Massive Datasets textbook, because some of the techniques you need to deal with very large-scale data are new and different than if you can use or fit all the data you have in memory on your machine. And now it's very easy to get really large-scale data from places like social media or stock market, historical stock market data, etc., click log data. It's really easy to get very large-scale data quickly. Then the course will cover the complete analytical funnel from data extraction to cleaning to data analysis and insights, interpretation, and visualization. Hopefully you'll get experience with this through your Medium posts, the homework that I'll talk about, and your semester project. Your project especially asks you to identify a data set or a set of questions that you want to answer, that you can answer with a data set, extract that data, clean it, do some analysis, and then communicate that analysis to hopefully non-experts. The rest of the course, data analysis components will focus on techniques, so we'll talk about supervised and unsupervised learning for information extraction, clustering, regression, and a lot of this will be done through homework assignments and a project. We don't really have in-class activities for the online portion of the class. I won't have exams, but you will get practice working with these techniques and tools for both structured and unstructured data. So that's the course. It's breaking down what the course catalog description is. If I needed to summarize, though, I'd say this course is about extracting knowledge from data. Now, not all the data that we have is the same as knowledge, so you can extract huge volumes of data from social media, from Wikipedia, from click logs, etc. But just having that data is not the same as knowledge. Knowledge is about extracting insights. And we need to do something to the data in order to get this knowledge out. So what do we need to do? Oftentimes we got to collect the data, we have to store it somewhere, and then once we've stored it, we have to analyze it. So if you break this down in terms of the kinds of classes or techniques or expertise you may need for this class, for data collection, that's about web programming and APIs. That's the last bit of Module 1 we'll cover next week. You have to have some experience with storing the data. Fortunately for us, we don't have to rely on very sophisticated things for this class. Maybe you store things in JSON or CSV files, but also you could store them in databases or data lakes. That's not so much the purview of this class. Other sort of data management classes, I'll leave you for that. And then analysis. So really the core of this class is about the analysis piece. This is the data mining and data science piece of this course. So what is data mining? Data mining itself is sort of a nebulous concept, but it is a very common concept, so you hear it thrown around with data mining or data science classes, data science programs, all these things. So what is data mining and data science? So data mining is one thing it is not. It is not the same as machine learning. So in fact, I'd say it's data mining is a intersection among a number of different spaces. But I want to make it clear when we talk about this class, there is a clear machine learning component, but there are things about data mining that are not necessarily machine learning. Many things in data mining include the use of machine learning models, but they don't have to, because also part of data mining is about extracting and visualizing insights. You don't necessarily need machine learning to be able to communicate that information and visualize insights. And not all the kinds of insights we care about require really sophisticated models. In fact, many things that you might want to do with data don't require really sophisticated modeling procedures for machine learning, but do require lots of text filtering or being able to deal with things at scale. And we'll see examples of that throughout the semester. Speaking of going throughout the semester has 7 core modules for this class. In Module 1, we're going to really introduce data science and motivations, so partially those introductions are in the lecture for this week. Next week, we'll have more clear examples of data science, what that looks like, what those motivations are, how we deal with them. Module 2 is taking this idea of data science and its motivations and then applying it to the web and looking at the web through the lens of graphical models or graphs. So treating nodes or treating websites on the web as nodes and links across websites as edges, or nodes could be users in a social media network, and then the edges might be friend-follower links. There's huge volumes of graph structures on the web, and there's a lot of insight you can mine from them. In Module 3, we'll go beyond just extracting important nodes in a graph to being able to do similarity comparisons. How do you know when two websites are similar or two users in a network are similar? How will we use hashing to deal with large-scale data sets? There's lots of cool and useful tricks for hashing. And then we'll talk about dimensionality reduction when we have very large dimensional data, like you're doing using social media data and you're looking at individual words or individual hashtags or websites. Maybe you want to compress that down to a reasonable set of dimensions or an important set of dimensions. How do you do that for web content? For Module 4, we'll build on those pieces to actually move into clustering. So grouping a bunch of content together based on similarity, based on content that's been reduced in dimensionality. Talk about that. Clustering is also a form of unsupervised learning, so we'll introduce unsupervised learning pieces there. Module 5, we're going to go back to some basics about probability and Bayes and Bayes' theorem, because that'll set up what we need for Module 6 in supervised machine learning. So we'll go from the unsupervised learning and clustering. We'll bridge that material to the supervised machine learning case using probability and Bayes' theorem. And then finally, we'll talk about how do we evaluate how well our models work. So if we're talking about social media content or models on extracting like a particular kind of social media content, how do we know that our model's doing a good job here? A note, though, when we talk about this course and the focus on real-world large-scale data sets. And so I won't push you so much to focus on extremely massive data sets. That's more of a graduate course. But in the MMDS, there are some chapters about how to deal with really, truly massive data sets. And social media can very quickly become massive in terms of size or in terms of graph size, all kinds of ways you can deal with massive data. I won't push you so much on making sure you learn Spark or anything like that, but if it's a thing that you want to explore, so for large-scale analytics, that's a thing that you're welcome to reach out to me and we can discuss. Maybe it's a good opportunity for you to explore with your semester project. All right, so those are the 7 course modules. I want to talk briefly now about the 6 core learning objectives for the course. So the first one, you should be able to collect and clean large-scale data sets at the end of this course from a number of different sources. Hopefully looking at social media data is a good place for this. There's all kinds of good examples about extracting data from Twitter or from YouTube using APIs. Also using Google BigQuery or databases like this that already have large volumes of data in them. And then there are large collections of public APIs where you can go to collect your own data that's more specific to something you want, about weather, about stocks, about taxes, about all kinds of different sources of information. The idea is you want to be able to collect and clean data from these spaces once you have experienced this class. The second learning objective is articulating the math behind machine learning techniques, specifically some supervised and unsupervised learning techniques. For unsupervised learning, as I mentioned, this is a good example is clustering. Clustering relies heavily on being able to do distance evaluations. So you want to understand whether 2 points are similar or 2 elements are similar. How do you calculate that? There's a lot of distance metrics that we could use there. Hopefully you'll get some clear insight about the math for that. And then for supervision, I want to give you some insight, some foundation of the math behind supervised learning as well, whether it be simple classification or decision trees, what have you. And here on the right, that's the general objective function for sort of a linear, ordinary least squares regression model. You'll get some insight into those as well. The third learning objective is actually taking those techniques that you learn the math for and executing them to do clustering or regression models or classification in some higher dimensional space. The fourth one is to be able to select and evaluate different kinds of machine learning techniques. So there are a number of different points about this. Not every single machine learning technique is valuable or useful for all tasks. In particular, you will use unsupervised learning or clustering for one set of tasks and supervision for a different set of tasks, but not all supervision tasks are the same. You may approach classification differently than regression. Classification is about what group does this belong into? What kind of fruit is this, or what kind of food is this? Whereas regression is about scoring in some way, and where these tasks are used are different. So you'll get some insight about when do you want to select one or the other, when is one most valuable or more valuable than the others. The fifth one is explaining the results of these models. So it's not just about being able to understand and execute these models. You also need to be able to communicate what the results of these models are to a larger audience. The main way you'll do this is through actually writing about them through your Medium articles and for your final project. And our final learning objective here is about evaluating how well your algorithms and tools are working for your data mining task. Now, this evaluation includes hard metrics like accuracy and precision and recall, these kinds of core metrics that you need to understand, how you apply them using things like cross-fold validation, but also different kinds of evaluations that are more pro-social or normative, trying to understand, well, what's the sample bias in our data set? What is the biases that are being introduced by our algorithms? There's a separate kind of evaluation that you'll get, hopefully you'll get some experience with as well. The next thing to talk about is the course schedule. So as I mentioned, we have 7 course modules. Generally, we'll take 2 weeks per module. So that means in week 1 and 2, this is going to be focused on module 1. Weeks 3 and 4, it's going to be on graphs in module 2. Week 5, we're going to focus on similarity. And then week 6, we're going to finish up module 3 with hashing and dimensionality reduction. Week 7 and 8 is going to be clustering and unsupervised learning. Then you get your break in the middle of March for spring break. Weeks 9 and 10 are going to be your probability weeks. So week 9 is focused primarily on refreshing probability. Week 10 is Bayes' theorem and applications. Week 11 and 12 are supervision or supervised learning. And week 13 is model set and evaluation, the 1 week or the one module that we only focus on for 1 week. Because on week 14, you'll have your presentations. The last week of the course is going to be you're taking the opportunity to present your semester project to your fellow students, and your fellow students will help grade you on them. And then you have your final report for your semester project due on May 18th at the end of the semester. Also, throughout the semester, I will provide you readings at the beginning of each module. So essentially, what will happen is every week I'll make announcements, and in those announcements I'll have a list of sections that you should read, either from the MMDS or from the IMLP, particular chapters or particular sections. I won't ask you to read the full chapter the vast majority of the time. I will ask you to read specific sections over the course of the semester. So if you go look at Canvas now, I already have a list of sections in MMDS for you to check out. It's important that you read these sections. I've tried to make sure that the sections are not, or the reading is not burdensome, and I do not expect you to have a complete understanding of all the elements or all the details in these sections, especially in MMDS where there can be a lot of involved math for dealing with like clustering or dimensionality reduction. It's much more important that you read through, get familiar with the terminology and the language, so when I talk about a particular concept, you're not totally lost about what I mean. So yeah, you should read before you watch the lecture videos throughout the semester. Now, the thing maybe you care about the most is about grading and distribution, because that's really what you take away from this class is how well did you do in the class. There's the non-tangible things. I hope you learn a lot from the class, but at the end of the day, really you're aiming for a grade, I suppose. So there are 4 parts to your grade. Actually, really there are 3 parts that I'll talk about. There's the module assignments. So there are 7 modules. Each module has or ends with a medium article associated with it, where you write some article. I think with the exception of Module 5, I don't have one for probability, because during that time frame there's a semester project piece due there. Then 40% of your grade is based on the final projects, or at least the different portions of your final project, which I'll talk about in a few minutes. And then finally you have participation. This is a little bit cumbersome maybe in the online world with the online version of this class, but I'll have some examples of that too. Crucially, in this class, for your homeworks, for the module assignments, my late policy is that I do not penalize you for being late. There's some decent research showing that penalizing students for late assignments does not help them and encourages them to not do the work after they've passed the deadline. So instead, what I do is your module assignments can be turned in whenever you want. Though I encourage you to not get behind on them, so you'll have 6 different 500-word articles to write, and you don't want to be writing all those at the end of the semester, and I certainly don't want to be grading all of them, or Tanish doesn't want to be grading all of them at the end of the semester. We'll be unhappy with that. If we're unhappy with that, that's probably going to be reflected in your grade subconsciously. You don't want to do that. So a good way to keep track throughout the semester, I have provided you due dates that are suggestive in Canvas or in Elms. You can check that out. But a good way to do this also is to look and see, well, how many of your fellow students have also submitted their work already, to give you some baseline. That late policy, though, is specific to the module assignments. For your semester projects, the due dates for the semester projects are mostly strict. Primarily, that means your intermediate report and your final presentation and your final reports, those are strict deadlines. If you cannot meet them for some reason, you need to let me know. Because the intermediate report, there is a peer review component there. Everybody needs to have their content in to actually do the review. And for the final presentations, same thing, peer review components. And your final project report, that's at the end of the semester. So if you wait longer than that, I won't be able to give you a grade just because I have to get grades in. So yeah, I'll be flexible about this. If you need additional time for any part of the semester project, please reach out to me. Other policies associated with the class, so you can check out the Maryland course policies on the website. In particular, though, there's the policy on academic integrity I want to point to. So for this class, there's a data mining or a data science component to it, which means there's a programming component. There's always the attraction of Stack Overflow for this, so copying and pasting content from Stack Overflow. Now, in general, I have no problem with this as long as you are citing where your analysis comes from. So as long as you say, well, I got this code block, or I saw how to do this code on this post or from this blog or whatever, as long as you're citing that way, that's fine. If you're not citing your content, or you're not saying where you got data, I'll very easily or very quickly pick that up. It's not very hard to like Google search particular phrases in your writing and then see that this sentence that's in your post also is in this website here. I do that quite often. The main thing though that I will say is do have an understanding of how the code works, and I will be particularly unhappy and intervene on academic integrity issues if you put in content that suggests you've done analysis that you actually haven't done. So if there's a line in your article that says, I did this analysis, and then you are passing off analysis from some other website as your own, that's going to be hugely problematic. Please do not do that. All right, quickly to talk about the module assignments. This is your homework for the semester. There are 5 assignments, or 5 plus 1. The first module assignment is a medium sign-up assignment, very easy to do. But the core assignments here, assignments 1 through 5, end every module, or the bookends to every module, and come in the form of medium assignments. So why am I doing this? What does this mean? So essentially, I expect you to write an article, essentially a report of some form, describing a data mining technique that you've applied using data that you either collected or found to answer some question or provide some particularly useful insight. Partially I do this because that's part of the course requirement, or the ability to communicate and explain your results is a part of the course requirement. This is one of the objectives we want you to take away from this class. But also, there's good experience that suggests Medium posts and their public nature, the fact that you're posting an article that the whole world can read, leads to higher quality work. You're not just writing this for me, you're writing this for the general public. In addition, the content that you write here can be useful for your own portfolio. So I've had a number of students over the years who have written posts on Medium that got picked up for other publications, got them traction with new networking opportunities. So there's real value, I think, in the public-facing nature of the articles you write for Medium. So if you have an issue with Medium, I should update this slide. If you have an issue with Medium, you don't want to use Medium, please email me within 2 weeks. This should be by the end of Module 1, so we can come up with some accommodation for you. You can see some examples of what I've done in the past. So if you go to medium.com, web mining IS688, this is when I taught this version or version of this course at NJIT last spring. You can see some examples there. Or you can see some examples from University of Colorado Boulder, where Brian Keegan has done this as well in his Information Expositions course. So I'll have another set of material on Medium that I'll post separately about how to create an account, write articles on Medium, and then add them to the publication, the course publication. So as you'll see, assignment 0 is signing up for Medium. You need to do that so I can add you to the course publication. That way I collect all of the Medium posts for the course on this course publication. That makes it easy for anybody to go see all the assignments for assignment 1, what kind of analysis were people doing there, all of the assignments for assignment 2, what kind of analysis were people doing there, or for module 2 rather. So I'll post more material there. Please get your Medium account information to me quickly. So that's the homework. The other major portion of the class is your semester project. So your semester project is, I think, 5 different pieces. It's really meant to give you an opportunity to go deeper on a particular topic that you may care about. So over the course of the semester, the module assignments are getting you to exercise specific techniques. The semester project is about getting you to hopefully apply as many techniques as you can to a consistent data set, to extract as many insights as you are able, as many insights that you find actionable. So the first part of this project is the project proposal. This is where you share what you want to do, who's going to be doing it with you, these kinds of things. Then you have a data collection report, which lets me know that you've at least made some progress in collecting the data that you need. That's core objective of the course, is to be able to do this collection. Then you have the intermediate report and review. So this is about halfway through the semester, where you share what your progress to date is and get insight from your fellow students about how well this works, how effective are you at communicating what you're doing, and then you'll get feedback from them that you can use for your virtual presentation at the end of the semester. And then finally, you'll have your medium report that will bookend the whole project to do at the middle of May. So those are the 5 main projects, or 5 main elements of the semester project. So what kinds of things can you do in your project? Some examples are taking the techniques we've learned in class and then applying them to real-world, large-scale, or web-scale data to extract some sort of insights that are unique and interesting. You can take a number of different techniques from the class and do a comparison, and then the insight that you extract is which of these techniques is somehow better for your particular case, and then doing some analysis about the advantages and disadvantages here. Or you can identify or construct some new technique or an extension on some existing technique and use that or apply that to your data set of interest. So there's lots of opportunities for you to explore interesting topics here. If you have no idea about what a good topic might be, feel free to come talk to me during office hours. I also have a discussion forum where you can post this. Crucially, though, I'm pushing you to get started on your project proposals soon. So the project proposal stage is due February 9th. That's in about 2 weeks. The proposal is lightweight, so it should be about a 200-word document. You outline answers to these questions. It can change, so this should be somewhat of a fluid document. If something happens, you need to change how you are dealing with something or change the kind of data set you're using. We can talk about that. That's going to be generally fine. As long as you stay within the same vein of the kinds of analyses or insights you want to extract, that's going to be sufficient. So I encourage you to go post your ideas on the Project Ideas discussion forum. A couple of reasons to do that. One is to get some quick feedback from me about whether your idea is a good one, but also to get some feedback from your fellow students. Maybe your students are or your fellow students are interested in partnering with you. So post your ideas there, and that'll help you out. Some sample ideas for your project, a bunch of them. So one of them is to use a very large scale existing data set. So a core part of the class, or a core part of the semester project, is to collect your own data for the semester project. Here is a unique example where I do not require that. If you're going to a place like the Yelp Open Dataset, that data is very large, and the skills you have to exercise to clean that data or extract insights from that data are still really useful, even though you're not necessarily collecting it yourself from some API or doing some scraping. So you can use large-scale data sets like the Yelp Open Dataset or PushS Reddit Archive, etc., to do analysis there. So if you have the Yelp Open Dataset, some things you might do: can you predict ratings from review text? Can you cluster businesses together into similar genres? Can you recommend new businesses or new metropolitan areas given somebody's interest in other restaurants? So there's lots of opportunities there. Twitter is a good place for you to collect and do data analysis or data mining. So there's large data sets available for Twitter. There's a GitHub repo that has a bunch of them. You can predict Twitter engagement. You can identify COVID-19 hotspots. There's a initiative that I ran with some colleagues from Glasgow and INST, where we used social media to understand something about crises. This is the Incident Streams Initiative. We make data around 100 different crises or disaster events available for you to do analysis on. Maybe you want to identify people who are willing to volunteer there, or rank content based on priority. Identify rumors during emergencies. Lots of examples there. Some people in the past have done sports team predictions. Maybe you want to do something like build a model for fantasy football prediction or fantasy basketball prediction, or predict who's going to win the NBA finals or the NBA tournament. You can check that out. Lots of opportunities there. Throughout the semester, you'll see me refer to this public APIs page on GitHub. Huge volumes of data that you can pull there for predicting flight prices, doing traffic congestion, identifying subways that are likely to have delays. Really lots of data that you can pull from there. Google has a number of APIs for its Google Books. You can do analysis on language in books. You can do stock market prediction. This one is always popular. Other opportunities from Trek are like news-oriented, identifying article authorship or recommending articles based on linkages or articles that are important background for other articles. A number of these tasks in the Trek context are all motivated by particular use cases. So those are examples of things you can do. There are also examples of things you should not do, or things that I'm going to be unhappy with, or things I'm going to give you a lot of feedback about not doing in your project for your project proposal. So do not propose a project that is just sentiment analysis. There's lots of ways to do sentiment analysis. Many of them are problematic. And if all you're doing is trying to take a bunch of social media content or take a bunch of reviews and identify whether the content is positive or negative, that's generally not enough for the semester project. A lot of that is somewhat kind of obvious counting or obvious analytics. The tools that help you do sentiment analysis are such that it's very easy to do that. So this kind of really straightforward analysis is not going to be sufficient for the project. If you want to include sentiment analysis as an additional thing, you're welcome to do that. So if you want to combine sentiment analysis in service of stock market prediction, or sentiment analysis in service of team winning prediction or something like that, you're absolutely able to do that. But just, well, what is a positive or negative tweet or a positive or negative review? That's not enough. As I mentioned, post your idea in the project ideas discussion forum. I'll give you feedback there, and hopefully you'll see what other students are thinking about. Lastly, a thing that I've found has been very useful for the semester projects is to have some kind of consistent touch point between me or the TA and you and your team. In the past, I've done this weekly. There are many of you, so maybe I'll do this bi-weekly here to facilitate this. But really, once we've got your teams in place, we'll figure out how many teams there are. And I want to set up these quick, brief 15-minute meetings where we just talk about how far are you, what issues have you run into, what kind of analysis have you done, what questions do you have, and what help do you need. These will all be virtual, and they'll be scheduled individually so we can make or find times that work for everybody. I found these to be extremely useful in making sure that the semester projects go smoothly. All right, so we've talked about modules, the module assignments. We've talked about the semester project. The last part of your grade is about participation. As I mentioned, this is somewhat difficult to do in an online asynchronous class, but I've already talked a good number of times about these discussion forums. So your project ideas discussion forum, the introductions that you need to be doing, all those are forms of participation, as are all the module assignments, or all the individual module discussion forums. Posting in there, those are all forms of participation. And there are a couple of assignments that are specific to participation, such as the peer reviews for the semester project. So that's the main way that you'll get participation credit here in this class. Lastly, for other ways to get participation is to come to office hours, either to my office hours, which will be Thursdays from 3:30 to 4:30, or Tanishk's, he'll have 2 sets of office hours, Monday and Wednesdays from noon to 12:30, and all of this is going to be on Zoom. All the information for that, I believe, is already I already put in Elms for you to check out. All right, so that's a quick overview of the course and its logistics. For next week, I will be giving you a stronger introduction to data mining and data science. What are those? What are examples of that? What are the techniques that we use? And to give you a foundation for that, I want you to read sections 1.1, 1.4, and 1.5, and review section 1.3 so you at least have a foundation of where we're coming from. And then also next week, we will introduce sort of a foundational piece or a foundational set of techniques in mining frequent item sets. So it turns out many of the data science and data mining techniques that you use can be reduced to finding items that co-occur often, two items that are similar or two items that will occur together. The frequent item set mining techniques that we'll talk about give you good foundations for how to do that. So to do that, I want you to read sections 6.1 and 6.2. Also, be sure and sign up for Medium. Get me your Medium account name so I can add you to the course publication. And introduce yourself. So as I mentioned, it's crucial that you do that so we can get an understanding of what you want to be called and your pronouns so we can refer to you correctly. And be working on or be thinking about your project proposal for your semester project. Identifying who's going to be in your group, what kind of problem are you solving. Try to answer these questions, or at least be thinking about answers to these questions, because that's due in 2 weeks. And post here in the project ideas forum to get ideas, share feedback, see what's interesting to you. All right, if you have any questions about anything related to the content I've gone over, or things that I may have missed that you're confused about, by all means post in the discussion forum. I will check those regularly, or you can come to me via office or during my office hours on Thursday. Tanishq will run office hours next week on Mondays and Wednesdays, or starting next week for his Monday and Wednesday office hours. Also, you can email me. If you do so, please prepend your email with the INST414 subject line that I mentioned in my email to you before. All right, thank you very much.